What if we know one trig ratio of a right triangle, but are not given a diagram or any of the side lengths or any other trig ratios? Let's explore this what if question using an example. In this example, all that we're told is cosine of x is equal to 7 over 25. And what we're trying to find is tangent of x. So what we can assume in this problem is that we're dealing with a right triangle because trigonometric functions are always dealing with triangles. And in our class, we're only talking about right triangles. So just to help us, we can make our own diagram of a right triangle. Since it's a right triangle, I'll draw my little right angle in the corner. And then our reference angle x can be either the angle in the top corner or it can be the angle in the bottom corner. Because you're drawing the diagram, it's really your choice as long as you draw it according to what the instructions state, which in this case is really not much. So then I'm going to label my reference angle of x as the bottom angle, that yellow angle. So now what we can do is we can label our triangle sides as opposite, adjacent, and hypotenuse. Pause the video for a second and label your triangle. It should be labeled like this. We are given that 7 over 25 is equal to cosine of x, which we know is equal to adjacent over hypotenuse. Now we can see that 7 is the adjacent and 25 is the length of the hypotenuse. So we can write that into our diagram. However, we still don't know the length of the opposite side. So we're going to have to use Pythagorean theorem just like we did in Objective 1 to solve for the opposite side. Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. In this example, a can be either 7 or opposite. We'll say that it's 7, b is opposite, and c is 25. Once we solve for opposite, we find that opposite is equal to 24. Now that we know all of the side lengths, we can solve for tangent of x. We know that tangent of x is equal to the opposite over the adjacent. So then the opposite in this case is 24 and the adjacent is 7. So we get 24 over 7. Let's try one more example. In this example, we are given that cosine of angle A is equal to 15 over 17, and that angle A and angle B are the two acute angles of a right triangle. And then what we're trying to find is the tangent of B. So let's start off by drawing our triangle. We know that the triangle is a right triangle and that A and B are the two acute angles. So that means that the third angle, let's call it C, is the right angle. We're given that cosine of A equals 15 over 17. And so the reference angle we're talking about is the angle A. So let's start by labeling our right triangle in relation to angle A. We have our opposite is BC, our adjacent is AC, and our hypotenuse is AB. Since those are all in reference to angle A, I'm going to highlight them yellow because our angle A is highlighted yellow. We know that cosine of A is equal to 15 over 17, and that cosine is equal to adjacent over hypotenuse. Therefore, 15 is our adjacent side length, and 17 is the side length of the hypotenuse. Once again, we have a side length missing. We again don't know what the opposite is, so we'll have to use Pythagorean theorem to find it. So by Pythagorean theorem, we know that 15 squared plus the opposite squared is equal to 17 squared. Therefore, opposite ends up being equal to 8. Now we're almost ready to find the tangent of B. However, our triangle right now is labeled in reference to angle A. We're going to need to relabel it in reference to angle B. When we do that, we find that the side length 15 is now our opposite. The side length 8 is our adjacent, and the hypotenuse stays the same. We know that tangent is equal to opposite over adjacent. So in reference to angle B, our opposite is 15 and our adjacent is 8. So tangent of angle B is equal to 15 over 8. And that is our final answer.